Hi, in this video, I will be showing you problem number 8 and 9 of the worksheet on chapter 7 for the intermediate algebra class. Graph the solution to the following inequality on the number line, x squared less than 4x. First, we will bring both expressions to one side and make one of them 0. So it's x squared minus 4x less than 0. If you factor, you get x times x minus 4 less than 0. So first we will find out the boundary points. X times x minus 4 equal to 0. So we will set it to 0 and solve for the x, which is x equal to 0 and x equal to 4. We have to plot these points on the number line. So x equal to 0, x equal to 4. So note that I have marked them as wholes and not as a solid dot. So here we have strict inequality. We don't have equal to signs, so they should be wholes. We are dividing the number line into 3 intervals, one from negative infinity through 0, then second one 0 through 4, third one from 0 through infinity. So as we did in the earlier problem, we are going to create a table, and we are going to take a test point in each one of the intervals and plug it into the inequality and see whether it is a true inequality, true statement or not. So we'll create a table. So we have 3 intervals, negative infinity to 0, 0 through 4, 4 through infinity. We'll take a test point in each one of these intervals. First test point is negative 1. Then plug it into the inequality, x times x minus 4. We have to, in order for the inequality to be true, it should be the product x times x minus 4 should be less than 0. So we plug it in here and we get the product to be equal to 5, which is obviously positive. So it is not satisfying this inequality, so which is false. So 0 to 4, take a test point. We can pick any point between 0 and 4. We are picking 1. So it's 1 times 1 minus 4, which is negative 3, which is obviously negative, which means the inequality is true here because it should be less than 0. X times x minus 4 product should be less than 0, negative, for it to be true in this problem. So it is true. Then I pick a test point 4 through infinity in that interval, which is 5. So if you plug 5 into the product, you get the value equal to 5, which is positive. So the inequality is not satisfied. So the inequality is satisfied only in this interval. That's the only one it is true. So it is 0 through 4 on the number line. That's a part you have to shade. But here make a note that 0 and 4 should be marked as wholes because the inequality is not a strict inequality. Problem number 9. Solve the following inequality. 4 over x plus 1 is more than or equal to 2. The first step is to move everything to one side. So 4 over x plus 1 minus 2 is greater than or equal to 0. So now we have to simplify this. It's 4 over x plus 1 minus 2 times x plus 1 over x plus 1 because we are making the denominator equal. So we are multiplying by x plus 1, the second term, which is more than or equal to 0. So if you simplify the numerator, it is 4 minus 2x minus 2 over x plus 1 is more than or equal to 0. Or it is 4 minus 2 if you combine the like terms. So it is 2 minus 2x over x plus 1 is more than or equal to 0. Or 2 times 1 minus x, if you take the 2 as common factor, divided by x plus 1 is more than or equal to 0. Now we have to consider 2 points for the number line. In order to find out the 2 points on the number line, set the numerator to 0. Also set the denominator to 0. Set the numerator to 0 and also the denominator to 0. So this way you'll get 2 equal to 2x or x equal to 1 if you divide both sides by 2, or x equal to -1 from here. So we have 2 points now, -1 and 1 on the number line. Note that here it has to write the solution in interval notation. So first we'll graph, then that will give us a better idea of to write the interval notation. So we have -1 and 1. So -1 is obtained by setting the denominator equal to 0. So that cannot be a solution to the problem. If the denominator was 0, then the rational expression is undefined when the denominator becomes 0. But the x equal to 1 is obtained by setting the numerator to 0. So x equal to 1 can be, should be a whole, or should be a solid point. Now we have, keep in mind that -1 is a whole because that is the one that makes the denominator 0. So that cannot be part of the solution set. Now we have 3 intervals as in the earlier problem: -∞ to -1, -1 to 1, 1 through inequality, 1 through infinity. Now the inequality that we have to check is 2 minus 2x over x plus 1 is more than or equal to 0 or not. So we are going to create a table and check the inequality. Now we have a table here. So we have taken -∞ to -1 and a test point in that one is -2. The inequality that we have to check is this 2 minus 2x over x plus 1. So that is the ratio that we have to check. If the ratio is more than or equal to 0, it is a true statement. So it should be more than or equal to 0. So we are plugging in this test point into 2 minus 2x. That gives us 6, and then x plus 1. If you plug in x equal to -2, that gives a -1. If you divide 2 minus 2x with x plus 1, you are dividing 6 by -1. That is obviously negative. So in order for the inequality to be true, it should be positive. So here it is false. So if you plug in 0 in the interval -1 to 1, that's our test point. And we get 2 minus 2x equal to 2 and 2x plus 1 equal to 3. Then if you divide these two, you get a positive number. If it is positive, the inequality is true. Then you take a test point 1 through infinity, test point 2 in the interval 1 through infinity. Plug in into 2 minus 2x, that gives a negative value. Then plug in into x plus 1, that gives a positive value. So if we divide one by the other, the ratio is less than 0, it is false. So the only interval it is true is -1 through 1. But here, when you write the solution though, the solution, here the inequality, here it is -1 to 1. Along the number line, if you graph it, this is the interval solution where the inequality is true. But when you write that as a solution, you have to write that as -1 through 1 in interval form. Because -1 cannot be the solution because that makes the denominator 0. So the inequality will become undefined. So it cannot be equal to -1, but 1 can be part of the solution. So this is the solution in interval form. Hope this video helps.